Good morning, all. This is lecture number 10 E512 CMOS device design. And today is September 19. Okay, so we are talking about various amplifiers like common source, common gate, and common drain amplifier. Common source amplifier is the one which is going to give you which kind of topology. Is it voltage control voltage source or voltage control current source, or which one it is? You can use this one, this place. So which kind of amplifier it is? I thought it's very easy. Voltage source, current source. Okay, what about common gate? What is common gate? Current control, current source. What about common drain? Voltage control voltage source, right? And common drain amplifier looks like this one. So we were talking about one thing when it's small signal AC gain which you are interested in. So I'm interested in small signal AC gain. At that time, VDD is AC ground, or it is treated as ground, and this particular transistor is getting tuned by the value of voltage V, and this particular thing is actually, if you look at here, you will see that it is tuning GMVGS, right? Along with, I'm keeping one by GMB, right? So it is tuning this particular part, right? I'm keeping here some of the things like RO and other things are with respect to VDD, but it becomes AC ground. That's why it is here, right? So we can say that this is like a circuit where this is getting tuned with respect to V in voltage, and this is actually 1 by GM. GM depends on V in value, right? So if I am interested in finding out V out, it's a voltage division between two different resistances. One is at this side, which you can name it as, let's say, R2, and another is 1 by GM. So V out by V in can be written as R2 divided by 1 by GM plus R2, where I know that what is R2 is nothing but simpler R0 in shunt with 1 by GMBS. Same is true for this one, so R0 in shunt with 1 by GMBS. This is what I wanted to explain last time, and maybe I went a bit higher side. That is what you were saying. So this is fine. This is fine or no? Right. So if this is the case, let's solve this particular circuit. Let's solve this. Let's call this one as V bias. This is V out, and this is V in. Let's call this as M1, and this one is M2. Can you tell me the small signal AC gain O here? got the answer? You got the answer? Why use use this, right? So what's the answer? What's your name?
Srishti.
Srishti. So tell me, what's your name?
So I got answer. I don't know why it's correct or not, but R not parallel to 1 by GM1.
Are not parallel one.
Parallel to 1 by GM1
Okay.
into GM2.
Into GM2. Okay. Okay. Let's skip this one. Wherever. First of all, which kind of amplifier it is? Srishti, which kind of amplifier it is? Like common drain, common source, common gate. Okay, let's go back. Just for my knowledge, okay. Those who missed it, you are coming from communication signal processing, or you took admission in VLSI? VLSI, okay. So, what is the gain over here? What is the small signal AC gain for this circuit? Hmm? Minus GM1 times RD and shunt with RO1, right? If it is like this, so what is the gain over here? Srishti, are you following, or? So what's the gain over here? This is M1. Yugal, what's the answer for this one?
So minus GM.
Okay. Go ahead. Whatever, like, do not get influence from someone else. Okay. Do not worry to give wrong answer also.
Not RD parallel RA.
R in. What is that R in?
So that
This is V in, right?
the resistance across B.
Resistance across V in. Across V in, it has to.
Resistance.
Okay.
Right now.
First of all, this is which kind of amplifier it is? Hmm? Yeah, it has to be positive. So which kind of amplifier? Yugal.
Common rings.
Okay. So first one is Srishti. What is the name of the first amplifier? Common source, common gate, or common drain? Hmm? Okay, very good. Common gate. What is this? It's very simple. How do you invented this is common gate?
So input is that.
Input is at gate. Very good then.
Output is
How to find out whether it's common source, common gate, or common drain amplifier? Somebody can help us. What's the name of those two girls? Yeah, two girls, both the girls. Huh. What's your name? Huh? Pragya, and next Ritika. Okay, so Pragya and Ritika. So tell me how to find out whether it's common source, common gate, or common drain
we
amplifier.
need to look at that terminal which is at the lowest potential.
Okay, AC lowest potential. Okay, you are right. Actually, AC lowest potential. So here I am applying AC voltage, which is not ground. I am receiving output over here, which is AC but not ground. However, this one is ground, absolutely ground, right? Right. So, what to call this amplifier? Srishti. Hmm? Common source. Very simple. Common source, and common source has a technique that we just look at from here and look at from input and output side, right? So from here it's GM1 and output side RD in shunt with RO1, right? These are the interview questions also, right? It's very simple, no? Is it simple, or because I'm teaching from many years, so maybe simple for me. So you have to tell me if I am going fast. Ritika, I am fast. What about you? T-shirt just in front of me. What's your name?
Panache.
Palash. Okay. So Palash, you took admission in VLSI or?
VLSI.
Okay. Who are the communication people? Are you able to follow because you are late or? Huh? Okay. No, you follow my lectures then. It is already kept up on YouTube. Just watch them.
Yeah.
Okay. So, okay, if you followed, then Palash, can you tell me what is the answer for this one? The correct answer. Look, these things has to be on your fingertip. Without using that, if you are going forward, there is nothing in analog. You can't understand it. So what's the answer? Narmit. Abhishek, yeah. Sorry.
I think it's GM plus GMB
GM1 plus GMBS1. Okay.
into RD parallel R.
Right. We can write down this as also eta plus 1 times GM1 RD shunt with R1. Right. Where this is theta times GM1. Okay. Now Srishti, tell me which kind of amplifier this is. Okay, should I give you some? Okay, tell me which kind of amplifier it is. You can use your hand also. You can throw that. So tell me which kind of amplifier? Common source. Why common source? Why? Still we are confused. Still, like if I am getting wrong answer, then I don't know. This has to be part of your previous course, previous analog you must have studied. So tell me, which one should I block? Common source. Okay, why common source? Okay, let's go this way. Just for my understanding that everybody are following. Yugal, which kind of amplifier it is?
Common source.
Common source. Okay, common source. Yugal. Okay. Anybody else? Common drain. Mostly all. Srishti, do you want to go with common source or common drain? Or confused? Confused? Why confused? Abhishek, can you explain why it is common drain? I am also with all. Okay. Common drain is the correct answer. Why it is common drain?
Because we are taking output from above the M1, but VDD is one which is.
So, first of all, look, those who are having the problem, let's repeat it again. You have to identify the transistor where you are giving the input. Let's go this way. So, this is the transistor where we are giving the input. Do you agree with this one? VB is a DC bias voltage. Everybody understand we are doing small signal AC analysis, right? When it's small signal AC analysis, all DC are equal to 0 volt AC, right? So in that case, this is equal to AC ground, this is equal to AC ground, this is equal to AC ground, this is AC some voltage of input which is not ground, this is AC output which is not ground, right? So the transistor where you are giving the input, in that transistor we have 3 terminal gate, drain, gate, source and drain. Whichever has the least potential or the minimum potential, that is acting as a common particular terminal, right? In that case, What should I say? Common? What's the name?
Vishal.
Vishal, yeah. Common drain. Do you agree? Yugal, do you agree with this common drain now or no?
Yes, sir.
Okay, somebody who has doubt, please let me know. What's your name? Abhishek. Okay. Abhishek. It's easy to remember. Okay. So this is common drain. Okay. Let's go this way. So tell me the gain of this particular circuit. This is M1 and this is M2. Use your notebook. You don't like notebook. Can I see your hand? Are you writing only that thing or something else? Okay. Hmm. I hope you are not getting bored, right? Here on the first position. Okay. I took you from there. Okay. Those who are getting difficulty in understanding, please, sit on the front side then. Okay.
So R equivalent upon R equivalent plus 1 by GM. Where R equivalent equal to GMBS plus
You just give it the direct answer. GMBS.
parallel to R naught.
Which GMBS? GMBS. Okay, you assuming 2 only, right? Okay, GMBS 2.
Parallel to R naught 1. Parallel to R naught. Same plus 1 by GM. So 1 by GM. Where
Hmm?
simple GMBS.
Is the correct no? I'm doing anything wrong? This is the correct, right? You got some different answer.
Yes.
Okay, what was that?
1 upon GMBS to
Hmm. Then? Okay.
reciprocal reaction GMBS.
Why GMBS 2 is like simple one? Look, GMBS is actually,
1 by GM.
yeah, the unit is mho.
Yes.
So it's not giving the dimension wise, it's not the correct one, right? It has to be 1 by GM, right? Yeah, Ritika and Pragya. Got the answer or going fast? You take help from him. He is doing correct. If you want, you can take from help from your neighbor. They are taking help from each other. Others also can take. Okay, let's keep one surprise quiz then. Okay, anyway, some people are not here. We can give them penalty also. Right? Keep one surprise quiz where I'll give you some questions. Okay, find out the game and look at all the source terminal, drain terminal, wherever they have been kept. Now do not copy from your friends. Okay, write your own answer.
So this will consider body.
Wherever you feel that body and source are not tied together, then of course body effect will be there. So when I'm not drawing the body terminal where it's connected, then it's PMOS bodies are connected to VDD and NMOS bodies are connected to ground. Okay, when you are completing with this one, then I'll go further. Or maybe I'll keep it here. So I want every one of you to get full marks. Okay. If you can answer all of them, then you understood this chapter. First one, any problem? This one, Srishti is easy for you. Tell me, what's the answer for first one? First one is the easiest one. I kept it for you. Okay. Other might be difficult. Other might be difficult. Abhishek, you got the first answer. It's very simple, right? Is it simple or no? What's the answer? Hmm? GM1. GM1. GM1 R1 parallel R2. So that's the answer from Abhishek. What's the answer? Vishal. So I consider this one correct answer or wrong answer?
So minus GM1 upon GM2 plus GM2.
Okay. So
No, I have not
yeah,
considered
yeah. So you just tell me the answer. Minus GM1.
upon GM2 plus GM2.
GM2. Okay. GM2.
Plus GM2.
GMBS2. Anything else?
Yes, sir. R1 sir, GM1 minus of GM1 into R01 parallel 1 by GM2 plus GM2.
Hmm? In parallel.
Yes, sir.
1 by
Shunt with RO2. ROT is also there, right? Output side. Oh, sorry. RO2 is not there. Sorry. ROT
not there. Yes, sir.
not there. So you can approximate it, right? Even you can approximate this to minus GM1 divided by GM2 plus GMBS2.
Yes, sir.
So that's the answer, right? What do you give? You understand, Abhishek? What was? So you are looking from here the source side. Just for trick, I kept all the questions. These are the tricky one. Don't jump into the answer very quickly without looking at all the terminals, right? But it's okay. People has to make mistakes also. Not, yeah, Yugal. By the way, all agree with this answer, right? Or lights. Visibility. So these are the interview questions people are asking. Very simple one. If you can't answer, then you are out of the game, right? What's your name?
Sign.
Sahil. Okay. Amit. Okay, कर लिया. And Santosh. Bedroom, huh? Or how many ones? Vivek, you got the answer? Okay, second one. और इसको M1 M2 बोल देते हैं, M1 and M2. Sorry? Okay.
Minus GM1 plus GM2 into R1 and
GM1 plus,
GM2
okay,
and with R1
R1,
parallel.
R2.
This one is in bracket GM1 plus GM2.
Hmm. Is it correct? I don't know. First of all, this whole thing, okay, multiply O here.
Yes, yes, this is multiplication.
Okay. I don't know. This answer I am writing with Vivek. Okay, I don't know the answer. Okay, you can write down in your one. Hmm? I don't know. Hmm? Body, there is no body effect, right? In this, there is no body effect because it is not shown, so it is like this. Okay, so how are you solving first of all?
Sir, GM1
GM1,
into GM2 parallel to R1.
this is one you want to write. Dimensions are not matching. How are you solving such kind of question? Look at this question number 2 and 3. How to solve that? Hmm? AC model, but look, in this there are two inputs. In this also, like easiest way is treat one transistor at a time. Other transistor input is 0, and then add both of them. So if only you are considering the fact that if I am not considering input to this one and this goes to 0, then what's the gain? And same way another gain, just find out and add both of them, you will get the answer. Use the superposition. Okay, so I'm not going into second one, I gave you the hint. Okay. What about third one? Second one you understand, right? I gave the hint how to solve it. Okay, you solve it. What about third one? Do not copy your friend. He or she might be wrong. Okay? Just for your, you write down whatever you think. There are no negative marking for wrong answers. Okay, I am going to correct these questions. Okay. कौन तो पता तो उसको तो मतलब और
वो सप्लाई टेस्ट में उनका सिर्फ पैसा नहीं प्रॉक्सिमल
ठीक है, we'll see. Do not worry about attendance. It is there. I do not care about attendance, frankly speaking. If you are coming here, please come here to learn. That is more important. And your lectures are also there.
some content like slides. We were discussing slides to upload on Moodle because
I'll keep it. Don't worry. I'll keep it. Last few weeks were very hectic for me.
sometimes people like me are a bit slow to stay with
No problem. No problem. I'll keep those. So Vivek and Santosh, can you do one thing? Can you write down the lecture notes? Good lecture notes in latex.
You upload it on YouTube, that can be done. But the slides people.
I'm talking about slides only. Slides are ready already. I'll keep it on Moodle. It's not a big thing. I'm talking about the lecture notes. It is separate one. So we are going to keep that. Okay. So tell me, which kind of amplifier are you seeing? Common gate, common drain, or common source. Two inputs means you have to use superposition, right? So then, if you consider input at the gate, source becomes ground. Then it's a common source. If you are considering input at the source, gate goes ground. Common gate. Use both of them. Add both of them. Why 0? Okay. So one of the condition does not have body effect. Look, if it is common source, there is no body effect. So there is no GMB, right?
Sir, GM1 plus GMB1 into R0
GM1,
into plus
okay, plus
GMB1
GMB1
into
into
R01 shunt with R02
R01 and shunt with R02. Okay,
minus
minus
GM1
GM1.
into R01 shunt with R02.
Okay, you can use that. Some part will go and answer will be eta times GM. Right? Not 0. Right? But till now you understand when to take body effect. When to take body effect. Want to consider body effect. Not tied together. Right? Okay. 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 Go to the next question and solve that. Yeah, Yugal, tell me what is the answer? Last one. Simpler one, no?
But I'm not getting. I'll take some time.
So take help from other people. Look, that's what's your name? That oh, yeah, Gaurav. Okay, Gaurav, can you change your position to here next to Yugal? Can you go that side. एक वहाँ से वहाँ भेज दो.
Okay, I can.
Please help your friends also. Those who are getting the answer, please help your friends also. Okay, that is how you can learn, right? Palash, are you able to get the answers or?
Yes, I do.
Okay. Sit with some good students if you feel,
Yes, sir.
you know, or sit with weak students if you feel like to help. Help your friends. It's very simple. Right? It's whole mathematics, and that is how it goes in our course. Right? Is it which kind of amplifier? Srishti, this one. M3. M3. What is the problem? Gate is VB1. Gate is VB1. Yeah, which kind of amplifier? Common gate, common drain, or common source? Hmm? How did you invent its source? Same way you are saying source is connected to input, not the minimum one. Abhishek, which kind of amplifier this one is? Common gate. Somebody who has common source answer. Okay. Practice more. We shall explain you properly or no? Okay. Are you able to follow YouTube? What's your name? Gopal. Okay. So what's the answer? Is it difficult? Why difficult? Okay, what is the output resistance of this amplifier? Output resistance R out of this amplifier. So go to the output terminal and look at different terminals. So in this side, what I'm going to see RO1. What about this one? Looking into M2, 1 by GM2. Looking here, what I'm going to see 1 by GM3 in shunt with 1 by GMBS3. Right? It's a source terminal. All are in shunt. So the winning entry is actually 1 by GM2 in shunt with 1 by GM3 and shunt with 1 by GMBS3. Right? RO1 I can approximate. Right? Now the gain. This is which kind of amplifier? Common source? Common source? No. Okay. Common gate amplifier. So the answer will be positive, right? So what's the gain? GM1. Okay. GM1 plus GMBS1 times whole R out, whatever is written over here, right? That will make this gain equal to 1 plus eta times GM1 times R out, where R out is nothing but 1 by GM2 shunt with 1 by GM3 shunt with 1 by GMBS3. Yugal, are you able to follow or no?
Yes, I follow.
Because most of the time, even in slides, these things might not be written. Maybe like this, the slides where I'm writing, that also I need to add. Okay, I'll take that. Okay. No problem, right? Do you have any? So that's the end of this particular, chapter. And next is very important chapter, which is called current mirrors. Current mirrors are everywhere, or I would say that it's a, rather than calling it current mirrors, you can call it as reference current generator. So let's assume that you are the one who wants to have the current source. If you go to market, which kind of current source are you going to, buy? What specifications are you going to keep for any current source? Or maybe like voltage source is also there, but similar to that, current source. What are the specifications? If you are going for, let's say, mobile phone, you are seeing how much megapixel of camera and many things, right? So the same way, what are the specifications for current source, in your opinion? Current rating, okay, good. Output impedance, okay, very good, right? Minimum voltage, okay. Voltage, minimum variation, right? If I am going to talk about this in the other way around, if I am interested in current, any value of voltage, any voltage value is there, my current should not change. This is what you want. This is the meaning of actually what has been written over here. That whatever the current rating I want, maybe in some range, that current rating, for a given current rating, my current has to be stable. It should not be changing at all. and it gives what is the slope of this one. Slope is 0 means what is the slope actually? Slope is output resistance, right, or resistance. So okay, 1 by output resistance has to be 0 means R out has to be infinite. If you want a good current source from where you are taking the current, right, output has to be infinity. This is what we also learn. If you want a good voltage source, you replace both the sides, you will have slope equal to 0, so output resistance will be 0 in a case of voltage source. In a case of current source, good current source will give you infinite resistance, and we know that anything beyond 1 kilo ohm we are going to call that one as high, and high is actually infinity. This is just assumption, right? Okay, this is for just for our understanding, right? However, if you can achieve higher and higher resistance like 100 kilo, 1 mega, 10 mega, as high it is good. So ideally it has to be infinity, but it's not there. So it has actually some slope, and if you look at that, for some voltage is also there for which in that range it does not give you the required current. It's not giving you the stable current. So this is red color characteristic is the one which is going to be there for any current source, and from there only we have written that the voltage has to be minimum. This has to be as minimum as 0 as shown over here, and output resistance has to be infinity. However, it's not possible to achieve infinity. There has to be some resistance, right? If it is 1 kilo, you will see more slope. If it is 100 kilo, little bit smaller slope, but you are going to see some slope for sure, right? So these are the important things. Please keep it in your mind forever. For any current source you want to have, it has to has, of course, the required current rating, and two important parameters or the specification wise which we need to achieve are output impedance has to be infinity and this has to be 0. If you can achieve this, you have a good current source, right? So this is what you want. What we are going to do with this current, by the way, the current is going to be used many places. Wherever you need the current, you are going to use it for biasing particular circuit. For biasing means giving the or keeping the particular transistor in a particular state, right, or the region. So that is depending on this current also, right? So current is required. For many places you need the required current 10 micro, 20 micro, 30, 40 micro, whatever you want, you can use it. But generally, if you have learned something, for each and every circuit, wherever any specifications we are writing, we have to understand at the back of our mind that everything has to be PVT independent. What is PVT, by the way? Process voltage and temperature, right? For any process, any voltage or any temperature variation, my circuit has to be resistance enough and it should give you the required specification over the PVT, right? So what is the easiest way to achieve PVT? What have you learned till now to achieve PVT? Anything which you have learned in past maybe 10 lectures. How to achieve good PVT performance. Vivek, how to achieve good PVT performance? It is a difficult question, so I start with PST. Santosh, what do you say? Okay. Anyone? Any guess? Yugal. Yugal,
Yes, I'm just.
you are here. Anything. Any guess, we can keep it, no problem.
Result on our assuming PVT points should be minimum.
No, look, this is a general question for anything. This is not even for analog circuit. Any circuit which you want to make on chip, how to achieve PVT performance means you have achieved something on typical corner, and I want to see similar question, similar thing on slow corner, fast corner, everywhere.
So this is what I am trying to say, that you relate something to corners. So we
Yeah,
will
yeah.
have less number of corners.
No, that we can't. We need more corners only. Okay. Then you just leave all the corners, keep only typical then. Right? Any guess? So we must, like I already talked about it earlier. You might have forgotten, but do not forget it ever now. The easiest way to achieve PVT is the only way is good matching. Matching is required. Do you understand matching? What is the meaning of matching? What is the meaning of matching? Vishal.
Same.
Okay, same. If it is same, then what is
Ratio should be
ratio? Okay. So first thing is to achieve any circuit which is in ratio, it is actually a matching. Generally, if you use till now, you must have learned cadence where you are using Q, right? Actually, Q, right? Small letter Q. What Q does? It's a properties, right? Property of any instance. If you want to have it, press Q, right? So if you go to the transistor property, you are going to see following things. So major four important things are there: W, L, multiplier, and finger. These are very important. Maybe we can talk on maybe Thursday. That would be better, right? So we'll talk about it, and then we'll achieve the matched transistor and matched current, matched performance, right? But remember this: always you should use this one. Unfortunately, not written in any book. But maybe matching might be written, but not taught how to use it. Right? Okay then. By the way, did you able to achieve that CV curve for all the different topologies?
Yes, sir.
Was that as expected one or something else came? What's your name? Suraj. Okay. So Suraj, you got all the answers? So I learned one thing from Punit that when you are submitting the report, it has to be in LaTeX, IEEE standards, and it has to be very well written. Understand? Okay. So if it can go to minus also if you don't work it properly. Okay. So give your 500% in that. It will be difficult to score in exam. Okay. So it will be like this only. Whatever I kept today, some examples where you are not able to give the answer. Like it may be anything, right? I can give I can give the input from body also. Understand? So anything like if you can perform outside the exam center, then you will be able to perform more and you will get good grade. Do not take it lightly. Okay, so wherever the reports are there, if you need any problem, anything is there, we can help you. But write a good report. Do you have some previous reports, right? Nazrul must have when he was my TA. Tanmay is very good. Have you seen Tanmay's report? Tanmay, he was my BTech student. He's very good. He is excellent. So he has written good report. He got O in both the courses, right? So in digital as well as analog. So if you took both the courses, including he took that laboratory also, right, with me, that IC design. So you just look at his reports. He has written very nice report. Mostly he used to get 9, even though it was good. So I was giving him one scope to improve. I was deducting 1 mark. So do not give 10 marks to anyone. Okay. So when somebody is getting 10 marks, then show me that report. We'll show it to everyone. Okay. Try to make good report. Good report is the most important part, right? Use X circuit for drawing any circuit. Do not copy. Or if you like Xfig, whichever software you like, you can use it. These are the open source, right? So then you can have EPS, encapsulated PostScript, right? Use LaTeX. These things will be useful when, like, when you go outside also. You will know that this has lots of impact on your manager. Your manager will be happy if you are writing good reports. Right? What you are writing is not sometimes. What you are doing is sometimes not important than what you are writing, because that goes to the repository of your company. Right? Same way, we'll keep it in our repository. Maybe your juniors will also see that what you have done. Right? Okay. Thank you for today.